Alright, boys and girls, let's get started with Chemistry Vodcast 1.4. We got a lot of stuff to cover. I'm sorry this is a somewhat long video and there's not a whole lot of extra fun video stuff in it. We'll make up for that next time. We're going to start talking about the SI system of units. These are the units that we use in science. You've probably heard of this before, called the metric system. That's usually what it's called in elementary and middle school. It's technically the SI system. There's a little bit of difference, but same thing for us mostly. So the things that we're going to be using for most of our measurements, we're going to use the meter. We're going to use a lot of the liter in chemistry class. We're going to use grams, okay, instead of pounds. And we're going to use something called moles a lot. We're going to talk a lot more about that later, but that may be the most important of these things in chemistry, but you won't really know what that is. Just know that it's an SI base unit at this point. The SI unit also uses prefixes, okay, and you should know these or remember these from elementary or middle school. Kilo, deci, centi, milli. These are all on your notes. There's a table of them in your notes, and you'll see some like mega and micro and stuff like that as well. These are the four we'll use the most. We'll use micro occasionally as well. And you could see some of the others, mega, nano, pico, and we'll talk about those when we get there. They're on the table on your notes as well, though, so if you do see them, that shouldn't be too much of a problem. So the way this works is that you take a prefix here from the right, you take and add it to a base, and so that gives you a full unit. So we've got kilometer, okay, that would be km. That basically means 1,000 meters. Anytime you add kilo in front of something, it means 1,000 of whatever it is. A kilogram is 1,000 grams. A kilomole would be 1,000 moles. So one of the easiest ways to do these conversions, and we're going to learn the method in the next couple of podcasts about how we're usually going to do this, but one of the easiest ways to start out when you're just trying to figure out how to convert metric units is to use this little staircase. This is something that you can draw pretty easy. And then you can go up and down the staircase, and that will show you where you need to move your decimal places to do your conversions. So if you look on your notes on the page with the staircase, you can mark this stuff down that I'm going to write here on the staircase. And then we're going to walk through some of these examples that are on the page here. And I put more on the notes than you're going to run through here. But we're going to run through about 3 or 4 of them here before we move on to the density thing. So down here we've got micro, milli, centi, deci, and then one of the most important thing here is the base. Now what does base mean? Okay, base means it could be meters, it could be liters, it could be moles, it could be amperes, it could be any of those units that you've got on the table there. Okay, the base unit, the central unit. And then 3 steps up from that we're going to have kilo. Okay, and so the way that we're going to work these is if you look at number 1 on your sheet, where we've got 73.1 decigrams. Okay, so let's write that down. Maybe. So we get 73.1 decigrams. That's dg. Okay, little d, little g. And we want to convert that into grams. Okay, pretty common type of conversion. You've got one unit, you need to turn it into the other. So we go to deci on our staircase, and then we go up 1 step to the base. And it's not really a matter of up, it's that we went left to the base. Since we went left, we're going to move our decimal to the left, and we move it the same number of spaces that we stepped on the staircase. So we move 1 step to the left, we move the decimal 1 step to the right, and that gives us 7.31 grams. Okay? Ran through that one too fast. We're going to do several more, and then you can practice these on your notes as well. You need to fill these in. So if you look at number 3, we've got 0.0043 liters. Okay. And we want to convert that into microliters. And I don't think the micro came out on your notes. That's fairly likely, I suppose. Go ahead and draw that in. That is the Greek letter mu. It's kind of like a U with a tail or an M with a tail on it. That means micro. So we're going to start at the base. That's liters. We're going to go down to micro, and that is 6 steps. It's 6 steps to the right. Remember, up and down doesn't really matter here, but left and right does. So we're going to go 6 steps to the right. And I think I put 7 here. But it's 6. Ignore what I typed in there. Okay. So we're going to go 6 steps to the right. 1, 2, 3, 4, 5, 6. We move our decimal there, Any spots that are extra when you move the decimal, you fill in with zeros, and so we've got 4,300 milliliters. Okay, we're going to do one more here, I think. Let's look down at number 9. We've got 0.09 centimeters, and this is a case where it's really easy. You're going to kind of assume if you start with a small number that it's going to get a lot bigger, but that depends on which way you're moving on the staircase. In this case, that's not going to happen. So we start down here at centi, okay, at the C, and we're going to move up to kilo, or to the left to kilo. So 1, 2, 3, 4, 5 spaces to the left. Good news is I can count this time. So 5 spaces to the left. So put down your number, move 5 spaces to the left. Probably should have left myself a little bit more room here, but we still got 1, 2, 3, 4, 5 jumps. Fill in the extra jumps with zeros. Okay? And so we got 0.0000009. Okay? It gets real important that you count them up, and we'll see when we do our stuff in the next podcast that we're not going to do this actual conversion too much. Okay, so let's jump into density real quick. This is one of these like sort of trick question joke things. Which weighs more, a pound of feathers or a pound of bricks? Well, if you think about it for a minute, I mean, what does the question say? It says a pound of feathers and a pound of bricks. They weigh the same amount. It's a trick question because the difference is you would need a lot of feathers to make up a pound, but you'd only need maybe one brick, maybe not even a full brick, to make a pound. So what is the real difference in them then? If they both have the same weight, what's the difference? The difference is in density. Okay, the brick, everything's really tightly packed together, and the feather, not so much. Everything's a little bit more spread out. So that's going to lead us into one of our big math formulas, and this is a pretty easy one. D equals m over v. So the D is density, the m is mass, which is usually in grams, and if you don't already know, if you don't remember this from your middle school classes, mass basically measures the amount of matter in something. V is for volume. Volume is how much space something takes up. Okay, and we're going to measure that in things like milliliters. So you've got a 20-ounce bottle, or you've got a 2-liter bottle. A 2-liter bottle takes up a lot more space, has a lot more volume. Okay, and so it's a pretty simple formula. To find the density, then we're going to take our mass and divide it by our volume. That's going to give us our answer. Okay, so relatively straightforward. Remember that typically your mass is going to be in grams. Usually in most of the stuff that we do, our volume is going to be in milliliters or cubic centimeters. It's really important to know that milliliters and cubic centimeters are the same thing basically. Okay, they look different, but they are equivalent measurements. So 1 milliliter equals 1 cubic centimeter. So here's a problem, a sample problem that we're going to work through. What's the density of a metal with a mass of 45 grams and a volume of 12.3 milliliters? Okay, so the first thing we always want to do with one of these problems, if you have an equation, write the equation first. A lot of times in chemistry we won't have that, but if you do have one, write it down. Go back to your word problem then and mark down what each thing is. Grams are mass, milliliters are volume, so I'm going to mark those. And then we're just going to plug it in the equation. 45.0 grams over 12.3 milliliters. Then it's a matter of punching it in the calculator. When you punch it in the calculator, you get the usual big, giant, massive number, 3.6585365585. Okay, obviously that's not what we want to write down for answer, so we go to sig figs. Okay, our 45.0 grams is 3 sig figs. That 0 is significant. 12.3 is also 3 sig figs. We always go with the least number, but since they both have 3, that means our answer needs to have 3 sig figs. So we're going to round it to the hundredths place in this case. Since that's an 8 after the 5, it rounds up, so we're going to get 3.66 grams per milliliter. Okay, pretty simple. Not all the problems are going to be that straightforward. Where it usually gets a little harder for most students is that if the question doesn't ask for density, but it asks for either mass or volume, because this is an algebra equation, so if you have 2 of those 3 variables, you should always be able to solve for the third. So here's an easy way to remember how to do that. This is called the triangle method. So the mass goes at the top of the triangle, okay, because it's on top in the equation. Density and volume are going to go on the bottom. Okay, we're going to use this little square to cover up what we're looking for. If I'm looking for density, I cover up the D. If I'm looking for mass, I cover up the M. If I'm looking for V, I cover up the V. And what's left tells me what to do. So if I'm looking for V, I divide mass by density. Okay, mass divided by density. Pretty simple. We can go over that a little bit more in class if we need to as well. So for temperature, we're going to talk a little bit here about temperature conversions. So this is our three normal temperature scales. You'll see that they're kind of evened out here so that boiling point and freezing point are put together. And really what you need to know at this point is that there are formulas to convert them. So if you're in Fahrenheit and you want to get to degrees Celsius, this is the formula you use. You will use this one occasionally because we don't generally deal with Fahrenheit. We want to convert it to Celsius. The second one converts Celsius into Fahrenheit. Pretty unlikely you'll need that, but it's there anyway. And the bottom two convert degrees Celsius into Kelvin or Kelvin into degrees Celsius. As you'll see here, we're highlighting those. You're going to use those a lot. And they're pretty simple, adding or subtracting 273. We're going to do a quick Fahrenheit to Celsius conversion though, because this is the harder one that you might see yourself doing. So today outside it's about 90 degrees Fahrenheit. We're going to figure out what that is in degrees Celsius. So we write down our formula, just like we did for density. Always write down the formula before you start plugging numbers in. And yeah, that last number there, that's a 5. I have a real problem writing 5s on the board. Okay, and so we're going to take that formula, and where the F is, we're going to plug in our 90. Okay, so we got 90 minus 32. Okay, all of that times 5/9. So we want to do what's in the parentheses first. Remember your order of operations. 90 minus 32 is 58. We're going to multiply that by 5/9. Okay, just going to punch that in the calculator. Basically, 58 times 5 divided by 9. And we're going to get 32.2 degrees Celsius. Now, to be technically precise, we should have rounded that to sig figs. Should have gotten 30 degrees Celsius with no decimal. But you can sort of see how the process works. And we'll work through a bunch of these in class: density, conversions, and temperature. And hopefully you'll get them all. Thanks.